Okay, we're going to talk about the immune system today, and this is a good question to explain some stuff. All right, so 65-year-old woman has RA and enrolled into a trial for new medication after failing multiple disease-modifying anti-rheumatic drugs. A new treatment is CTLA-4 Ig fusion protein that blocks CD28 from binding to CD80 and 86 on antigen-presenting cells. Okay, so T cells, they need permission to be able to go do their thing, and we're going to be messing with that for our medication because RA is when we have super active T cell happenings in the body. Okay, so 1 month after starting the drug, she has less joint pain, so it's working. There's a decreased C-reactive protein and IL-2 levels, which the following is the reason for the improvement. Okay, it's going to be increased T cell energy. Okay, so let's talk about this. B cells, they make antibodies. Antibodies, they flag the bad guys in the immune system so that you can destroy them. And once a B cell learns an enemy, they remember it forever. That's like how the vaccines work. T cells, they don't make antibodies. They just give orders and attack. So there's this helper T cell. They tell the other cells what to do. There's the killer T cell, and they actually kill and destroy the infected cells. But for the T cells to work, they have to get permission from the, they only attack if the antigen presenting cell gives them permission. They have to get 2 signals. Okay, so how? Well, 2 signals. First, signal 1, recognize the enemy. So the antigen presenting cell, like a dendritic cell or a macrophage, has a little piece of the enemy, the antigen. And they use a molecule called the major histocompatibility complex. And the T cell receptor binds to this complex and it recognizes the antigen and says, hey, bad guy. Signal 2, they have to get a green light, co-stimulation. The T cell has a special button, let's call it CD28. Okay. The antigen presenting cell has a button called CD80 and 86. When these guys touch, then it's time. It's time to turn it on. So when the 28 touches the 80, 86, now it's fully on. So that's signal 2. They touch, antigen presenting cell touches the major histocompatibility complex. Once we have these 2 signals, now the T cell is activated. All right, so what does CTLA-4 have to do with this? Well, this is like a stop for all the T cells, hence the kind of the energy here. So basically, the immune system doesn't want to stay on forever. Otherwise, you get autoimmune disorders like rheumatoid arthritis, like the question stem. So CTLA replaces CD28. It's like a fake button, and it'll never work. And so the T cells can never activate, like the brakes on a car or like a fake button. So there's this drug, abatacept, which is what the question's about. And in rheumatoid arthritis, the T cells stay on too long and cause joint damage. And so we have a fake version of the CTLA-4. So it grabs that 80 and 86 before the CD28 can, and it blocks that go signal. Signal 2 can no longer activate, so you get less inflammation, no activated T cells, and less joint pain. Now let's talk about IgG and FC. So IgG, immunoglobulin G, it's a type of antibody. Antibodies are those like little Y-shaped things that help the immune system fight the infections, and it's the most common in your blood. So it's like the default weapon. FC, this is the handle of the antibody. The top part of the Y grabs the enemies. The bottom part, the FC part, attaches to the immune cells and tells them what to do. So abatacept is a fusion of the CTLA-4 and the FC portion of the IgG, so it lasts longer in the blood. Just a little bit of information, okay. So breakdown. T cells. White blood cells that control the immune attacks. They're doing too much. Antigen, the bad guy. Antigen presenting cell. These are the ones that they present the antigens to the T cells. And then they give the permission to attack through the 80, 86. That's signal 2. All right, major histocompatibility complex, a molecule on the antigen presenting cells that holds the antigen. So these guys are like, hey, here it is. MHCs. TCR, the T cell receptor. This is part of the T cell that recognizes the MHC. The CD28, that's the go button. This is the go button for the APCs, CD80 to 86. These guys touch. CTLA-4, that's the stop button. And abatacept blocks that stopping, or rather mimics that stopping. And it makes it so that these guys can never touch, and so the T cells can never be activated. IgG, common antibody, FC region, the bottom part. Okay, so we covered everything. So in summary, rheumatoid arthritis happens because the T cells stay on too long. Normally you need 2 signals, major histocompatibility complex and the CD28 to 80 to activate. CTLA-4 is a natural stop button that blocks that interaction, so you can never make it work. And this is a fake CTLA-4, the drug that was given, that keeps the T cells off forever. Less active T cells, less joint damage, less pain. That's why she's feeling better. So 65-year-old woman, feeling a little bit better. She tries abatacept. And why does this happen? We kind of already went over most of this. Hopefully that was Pretty simple. But let's look at the other answers. Okay, C3A and C5A, the inflammation alarms. These guys are proteins in the complement system, and they help just kill the bacteria. And they call in more immune cells and make blood vessels leaky, causing more swelling. But abatacept does not affect the complement system, like that kind of swelling, leaky blood vessel system. It works on T cells. Okay, immune complex. That's the trash disposal. So clumps of antibodies and antigens that build up and cause inflammation. These are the immune complexes. The liver and the spleen help clear those complexes, but here again, we're talking about T cells. Central tolerance. Okay, so when T cells are made in the thymus, they go through this training program. And if a T cell recognizes its own body, then it gets killed. And this is called central tolerance. Okay, so if you're making stuff that fights your own body, you don't want that. So you need, they develop the central tolerance for themselves. Not a good, nothing to do with this. Increased T cell energy, the power off mode. So energy is the T cell stays off and it doesn't attack. Energy is like, hey guys, we've had enough. And this is indeed what's happening. Abatacept blocks that co-stimulation so the T cell can never activate. So it's the power off mode, and that's what's happening. Sensitization is when the body makes IgEs against an allergen, and that's a different pathway. All right, so hopefully this was helpful. The immune system, immunology questions can be really tricky, but just remember these 28s and the 80, 86 stuff on the antigen presenting cells is needed for T cells to activate. So if you interrupt that, they won't activate. So it's the energy is going to be the correct answer for this question. And if this was helpful, then please just like and subscribe. There'll be more videos to come.